This is the second example on multiple factoring methods. This time we're going to start with something that has 4 terms in it. So based on prior experience, we think that we maybe should jump to this factor by grouping thing first. However, you always want to start at the top of the list and work your way down. So we're going to start with the greatest common factor, and this has a greatest common factor of 5. Now I do recognize that I've pulled out my common factor, and what I'm left with is 4 terms without a common factor. So I'm going to go ahead and jump right to the factor by grouping method. Again, the greatest common factor is going to get left on the outside of the parentheses until I'm ready to use it. So we'll create groups here. In the first group, I can factor out an x cubed. I'll be left with x squared minus 4. And in the second group, I can factor out a negative 1, and I'll be left with x squared minus 4. Finishing the factoring on that, I'll have x squared minus 4 times x cubed minus 1. Now I'm ready to bring that greatest common factor back to my answer. So now I need to start this list again. I don't have a common factor in any parentheses. I do have a difference of squares in one parentheses, this x squared minus 4. So that will get factored to x minus 2 times x plus 2. Next, I'm going to go back to my list and I'm going to start again. Greatest common factor, I don't have one. Difference of squares, I don't have one. Difference of cubes, I do have a difference of cubes here. The x cubed minus 1 will get factored to x minus 1, x squared plus x plus 1, based on our rule. Now we start again. Do I have a greatest common factor? The answer is no. I don't have a difference of squares or the difference of cubes or the sum of cubes. I do have a trinomial here, but that trinomial came from using the difference of cubes formula, so that's going to be a prime trinomial. Then I'll look for a factor by grouping. Well, that's going to take 4 or more terms, which I do not have. I've completed my list, so this is the final factorization for our problem.